Thank you, Mr. President Thompson, Sir Wood, Minister Kraft, for this kind introduction. First, a few words of introduction in German, the legacy of my 6 years in Jena. Guten Abend, meine Damen und Herren, und vielen Dank an das British Council und die Technische Universität Berlin für die Einladung heute. Was für ein Zufall, dass ich heute die Queen's Lecture halten darf und nachdem Queen Elizabeth mich erst letzte Woche in ihrem Haus vorgeladen hat. Als ich am Buckingham Palace ankam, erfuhr ich, dass Prinz William, der Duke of Cambridge, mich begrüßen würde und wir uns dabei eine Minute unterhalten würden. Und sofort begann ich zu überlegen, worüber ich mich mit dem zukünftigen König am besten sprechen könnte. Und dann dachte ich an Sie und was für eine Chance. Ich fragte Prinz William, Your Royal Highness, nächste Woche werde ich in Berlin die Queen's Lecture zum Thema Klimawandel halten. Und gibt es vielleicht etwas, das ich dem Publikum von Ihnen ausrichten darf? Und der Prinz war zuerst ein bisschen überrascht. Und dann sagte er, aber sicher, wir müssen jetzt alle zusammenkommen, um Maßnahmen gegen den Klimawandel zu ergreifen. What an incredible year we have had with presidents and ambassadors and ministers and queens and future kings and movie stars and bloggers and incredible kids. Fridays for the Future, Extinction Rebellion, the tsunami of European members of parliament elected at the last election. 270 people in this city were in the streets in September, all asking for action on climate change. I have been waiting with a mixture of impatience and dread for this moment all my life. Impatience because as a scientist I was really impatient that finally our message be heard, and dread because, well, it's actually pretty scary to be up here. Today I will talk about the multiple phases of climate science and climate scientists, run you through the arguments for climate change, run you through the cutting-edge science, the future, and then talk about the choice, the future that we choose tomorrow. So my presentation has 4 parts. The first one is the physical basis for climate science, and it starts, of course, here with the global temperature record. So this is 170 years of surface temperature change from instrumental measurements, and it shows very clearly a 1 degree Celsius warming over this historical period. Given all the current knowledge, so the sum of the knowledge that we have on climate change, there are 2 things that we can firmly say about this record. One is that warming of the climate system, so that is the Earth, the climate system is unequivocal. And the second is that the warming of the climate system from human activities is unequivocal. Now, just to be sure that we're on the same page here, unequivocal means leaving no doubt, it's unambiguous. And I'm going to give you 4 reasons for each of these 2 statements. On the left-hand side, the warming is widespread. It is not regional warming, which would be a signature of natural variability. This is more heat trapped on the planet. There are independent measurements for this from large-scale land stations, from ship measurements, from ocean stations, and from satellite data. 2 and 3, these are also measurements here, global measurements. The top one is sea level is rising. And again, that's from the warming, it's from the warming of the ocean, which expands the temperature, the water of the earth and moves forward, upwards. Snow and ice is melting, and here you have the record of Arctic, 40%, more than 40% decrease in Arctic sea ice loss over just a few decades. The last evidence is the more complex, but is the one from a scientist you find, you see these pieces of evidence and you say, this is incredible. It's in fact the evidence of the acceleration of the water cycle, which you expect in a warmer climate. You expect the water cycle to accelerate, but you see it in fact in surface salinity. And the color here is the color of the ocean. So the Atlantic Ocean is more saline, and the Pacific is more fresh. And the contours are the contours of the trends in salinity. And you see that the regions that are more saline actually are becoming more saline through time, and the regions that are fresher are becoming more fresh through time. And this is such a crazy, important, beautiful piece of evidence of the acceleration of the climate change on the planet. On the right-hand side, that activities that is also unequivocal. There's also 4 reasons. The first one is the simplest, is because we understand the processes. For nearly 200 years, we know that greenhouse gases trap warming in the atmosphere, and for more than 100 years, there has been projection of increasing in greenhouse gases and how much warming this would put in the atmosphere. 2, the observed rate of warming, which you see there in blue, is more rapid than any centuries in the recent record, which you see over the temperature reconstruction. And that evidence is strengthening through time with the more recent warming. 3 is the most powerful. It is the combination of 1 and 2. It is the challenge of reproducing global temperature changes in models. It's the hypothesis testing. Climate change is a science, and as a science, we test hypotheses. And when using only known changes in solar and volcanic activities, as you see right there, all models, which are at the bottom, completely miss the signal. I don't know if you see this. No, completely miss the signal. It's only when human emissions are considered, like in this case here, that models are able to reproduce the trends. Let me do this again. So this is without greenhouse gases. The black line is the observation. And this is with greenhouse gases. Without greenhouse gases, with greenhouse gases. Without, with. There are uncertainties, of course, and I will come to that in a minute, but it's not possible to explain the warming, the recent warming, without human activities. Also, the best estimate we have is that the whole 1-degree warming here is caused by human activities, although obviously there is variability in addition. The 4th piece of evidence, and that is really my favorite, is that there is no alternative explanation. This is how science works. We have observations. You must explain the observations. You think it's something else? Fine. Show me the equation. Put it in a model. Show me that the numbers add. Untested hypotheses are not good enough at the moment. The science of climate change is certainly the most thoroughly scrutinized of sciences. In no other field is there a thorough assessment of the scientific basis every 5 to 7 years like there is in climate science, and in the level of detail that it is done today. The Intergovernmental Panel on Climate Change won the Nobel Peace Prize for its work in 2007, and you see it, the five assessment reports that have been published in 1990, 1995, 2001, 2007, and 2013. On the top left there, it's me at 4 in the morning at the UN approval session of the last IPCC report, so the 5th assessment report here. We worked through the night. We ran out of biscuits at 11 p.m., ran out of water at 1 p.m., but we carried on until the job was done, until the wording presented was as informative, clear, and scientifically correct as possible. Thank you. That's for the IPCC. Maybe you have asked yourself before now, I will not ask for a raise of hand, but you might have asked yourself before the question at some point, how bad is it really 1 degree warming? We have 1 degree difference in this room tonight, I'm sure, at least between the top and the bottom of the room. And sometimes 1 degree might be feeling quite good, actually. So why bother? And the reason is, in fact, here. The reason is because we are talking about planetary warming here, and it's like the body. You have all these animals that have different core body temperature. I don't know if you knew that orangutan, who looks actually approximately like us, have a body temperature of 33 degrees, while birds have a body temperature of 40 degrees. And you have this giant human in the middle with a body temperature of 37 degrees. And all these organisms have these different body temperature because of millions of years of evolution of regulating their internal organs, their organism through just the evolution, parallel evolution. And we're perfectly happy to live at different internal body temperature, but as soon as we get a fever, be it just 1 degree fever, we do start being quite uncomfortable, and 2 degree and 3 and 4 degree fever becomes more and more problematic. And in fact, the Earth is exactly the same. The Earth has an internal temperature which it has evolved. It has an equilibrium temperature that it has evolved towards over a long time. And warming of even 1 degree means that it's in this equilibrium in some of its core functions, like the water cycle, like the level of the sea, like the position of the storm tracks and the intensities of the storm, like the productivity of the biosphere that feeds us, don't operate normally any longer. So let me move on to the imminent future. So what we know about science is that every degree of warming of the global temperature matters. It is thanks to the IPCC that we now have a detailed view of the impacts of climate change at various levels of warming. I put here again the temperature record with the 1 degree warming. And at today's 1 degree warming, we already see quite some substantial changes. We observe for ourselves increases in the intensity and frequency of heat waves in particular, increases in the intensity of heavy downpours, so rainfall intensifying, increasing the risk of floods. As the temperature rises, thanks again to the IPCC, we see emerging large impacts in various components of the Earth, not far above 1 degree, corals, the Arctic sea ice ecosystems and biodiversity impacts appear there very rapidly. Above 1 degree warming impacts on water availability, agriculture, and risk to the economy become more widely visible and widely spread. Just above 1.5 degrees, and risk of tipping points and ice sheets become high above 2 degrees. And there are uncertainties about how big these impacts are, but it is clear that the impacts and risks increase with the level of warming. On the bottom panel here, you see the emissions, the evolution of the emissions of carbon dioxide, which is the main cause of climate change and of this warming, together with other greenhouse gases. And the color curves correspond to these various levels of warming. So below is the future emissions trajectory that we need to follow to limit climate change to any of the warming levels that you see at the top. Now, CO2 is a long-lived greenhouse gas, so that means that once we put it in the atmosphere, it stays there for a long time. And therefore, to stop further warming, so to stop the planet to warm additionally, we need to bring the emissions of carbon dioxide and other greenhouse gases all the way down to 0. and even below zero in some cases, so that we can offset some of the emissions of other greenhouse gases, for example, methane and nitrous oxide, that are difficult to bring down to zero. And you see this here, where there's a tiny line here, I don't know if you see it, gray line, where some of the scenarios actually cross zero. And of course, the faster we bring the emissions down to zero, the lower the rate of warming. And according to the medium estimates of scenarios, so net zero in CO2 needs to happen by 2050 to limit climate change to 1.5 degrees with 50% chances, 2070 more or less for all greenhouse gases, and roughly 20 years later for well below 2 degrees. It is clear that the commitments made by countries as part of the Paris Agreement today do not limit warming to these levels, but rather lead to 3 degrees warmer or greater if they are not met. One of the biggest sources of uncertainty in the projections of climate change comes from the response of the carbon cycle to the future CO2 levels and associated climate change. And to know what this response is going to be, we can look at the paleoclimatic record. And there are 2 pieces of evidence that are particularly informative there. The first one comes from the Paleocene-Eocene thermal maximum, is a period 55 million years ago, where the Earth was warming for different reasons, so balance between volcanic activity and erosion. And as with this slow warming occurred an event which was an outgas of carbon to the atmosphere, either from a permafrost release or from clatrate release, that led very suddenly in geological terms to additional warming of 4 to 7 degrees in the atmosphere. Now, this happened at much warmer conditions than today, but it does show that there are actually instabilities in the carbon cycles that could be set in motion if we really push the warming to very high level. We know at the bottom, the blue little icon here is the glacial interglacial variations in atmospheric CO2 over the past million years, which shows that, in fact, the response of the carbon cycle to a warming of the surface of the planet is to amplify warming. So the natural carbon cycle responds in a way that leaves more CO2 behind. At the same time, with those scenarios that I show here, there is an implicit assumption that we will be able to develop sequestration of carbon, so capture of carbon and sequestration on the ground. And that involves manipulation or management of the carbon cycle, for which we have, in fact, not that much scientific knowledge at the moment, whether this is feasible at the long term, whether the carbon would stay on the ground if we put it on the ground, and there's a lot of research going on over there about the potential and feasibility of these CO2 negative emissions. It is a bit crazy to have this information in hand about the necessity to bring the CO2 emissions down to net zero, and look at the world out there, how we are consuming fossil fuels like there is no tomorrow. So what do you do with this sort of challenge as a scientist? Well, just to say first that the climate change is in fact unfolding as predicted by scientists repeatedly and consistently over 30 years at least. And the community has been very vocal, so this is me here in Paris, the year the Paris Agreement was agreed. And I think that we have been heard, in fact. The Paris Agreement has an aim to limit warming well below 2 degrees and to pursue efforts to limit warming to 1.5 degrees, and to achieve a balance between the anthropogenic sources and removal by sinks in the second half of this century, and that is net zero greenhouse gases. The Paris Agreement is, in my view, a masterpiece of diplomacy. It has this clause in it where countries need to come back every 5 years and strengthen their agreement, their commitment. So I think that we need a bit of time for the Paris Agreement to work, and we need especially actions to back it behind. And I will come back to this in the last part of my presentation. But the objective is good. In the part 3 of my talk, I want now to take you through a little bit of the science. So I have indulged here to put my own science in this third section of my talk because it's fascinating science. The release of fossil carbon to the atmosphere from burning fossil fuels is the main cause of climate change, but this release happens on top of a very active carbon cycle. And in fact, there is 7 times more carbon stored in the terrestrial vegetation compared to the atmosphere. And so that includes the above ground vegetation, so what we see, trees and grass. It includes soils and it includes permafrost. And there is 50 times more carbon stored in the ocean than in the atmosphere. So this stock of carbon that can potentially interact with the atmosphere is very large. In the past decade, the anthropogenic perturbation has been important from burning fossil fuels, but also from release associated with deforestation and other land use change, approximately 13% of the CO2 emissions only. And of this CO2 emitted to the atmosphere, just under half stay in the atmosphere because of the absorption of CO2 by the terrestrial biosphere and by the ocean in response to this increasing CO2 in the atmosphere. So the carbon sinks, we call them, so the natural carbon sinks, we call them, on land and in the ocean, give us a huge favor by slowing down the rate of warming in the atmosphere, and how they are going to continue in the future. So their evolution in the future is particularly important for the evolution of warming in the future. And it is, in fact, one of the biggest sources of uncertainty in projections of climate change is what these feedbacks are going to look like, especially in a very warm future climate. It is for this reason that 15 years ago, as part of the Global Carbon Project, we decided to keep track every year of the 5 components of what we call the global carbon budget. And so the 5 components are 2 emissions, so emissions of fossil fuel, emissions of land use, so that's deforestation mainly, and 3 partitionings, so the partitioning among the atmosphere, land, and ocean. And you see them here. So at the top, you have the emissions, and at the bottom, year on year, you have the partitioning of the emissions between the atmosphere, land, and ocean. These 5 components are estimated almost independently from different parts. We're using different tools and different sets of data. This year, annual global carbon budget update. The one this year is coming out early December. We're working on it. I have the results. I will not tell you. What started as an exercise of outreach, in fact, quickly became an incredible, powerful tool for advancing the science. We have a problem in science. We have more than one problem, but one specific problem is that we have no institutional memory. Are there scientists in this room tonight? You will recognize the feeling that we write papers, publications, and we actually expect others will read them and take them on board and remember what we said. And the reality is that we move on, and we, in fact, forget, all of us, about sometimes our own results, surprisingly. And the annual update of the global carbon budget gives institutional memory to the carbon cycle community. And every year, if we haven't solved our problems, then they are still there, still visible for us to work on. It's been a really great exercise. And so scientifically, this carbon budget helps to see quickly what we know about the carbon cycle. And I don't know if you realize, but it's not a given that the 3 components at the bottom sum up to the 2 components at the top. It is not automatic that the sum of the sinks, ocean, land, atmosphere, would be equal to the sum of the emissions. So that means that we have a good understanding, in fact, consistent with a lot of observations which are included here as much as possible. We have a good understanding of the processes that drive the carbon sink, of their evolution in time, because it's also not a given that they would evolve in time consistently. And the biggest source of uncertainty, in fact, is the variability, we call it the carbon budget imbalance. And this is really precious in science because we have this imbalance, which is, the black line here is the reflection of the top. Did you notice this? So the black line at the bottom is the reflection of the top. So if we had perfect observation and perfect estimates, the sum of the 3 components at the bottom would be exactly the reflection of the top. And it's not exactly. There's some little variations here, 2 petagrams, that's about 7 billion tons of CO2 per year. And so the biggest source of uncertainty in the carbon cycle is the mismatch in variability on timescales of 2, 3 to 10 years, which you see here from the difference of the emissions. And sometimes this is caused by the carbon sinks estimates overestimating the sinks, and sometimes by the carbon sinks underestimating the sinks. It's unlikely to be caused by uncertainties in emissions because the emissions quadrupled in that time period, but it's most likely to be caused by inaccuracy in our understanding of the carbon sinks. And I think that improvements in the detection of CO2 by satellite will help fantastically here. But I want to dig a little bit into the variability of the carbon to go in the ocean carbon sink. And just to say that this carbon imbalance is what excites carbon cycle scientists at the moment. Everybody wants the carbon imbalance in their component because it's interesting, because it gives cues and this is how we move forward. I do want to spend a few minutes on the Southern Ocean. The Southern Ocean is the biggest single sink of carbon in the ocean. It absorbs about 10% of the human emissions we put in the atmosphere every year. It's very active because the winds are very strong in the Southern Ocean, incredible strong wind. You can see in this picture. That's why the UK government had to build the RRS Sir David Attenborough ship, more casually known as Boaty McBoatface. Remember that? So that we can go in the Southern Ocean and take measurements. Others, not me. And the measurements are shown on the left-hand side here. And my research group did an experiment some years ago, which I've repeated recently, to estimate what are the implications of climate change and variability over the past 50 years. And we've done this using a model. So models are a representation of what we know and understand about the processes. And in my group, we build and use an ocean carbon cycle model. This is one of the models used to assess the ocean contribution to the global carbon budget. And the 2 experiments are, first, you let the ocean, the modeled ocean, see the increase of CO2 in the atmosphere, and you estimate with this, through process understanding, you estimate the evolution of the carbon sink through time, and that's what you see here. And the second experiment is that you do the same, but now you impose on the model changing climate and variable climate from weather models, so from weather observations and estimates over the past 60 years. And when you do this, then what you see is that when you let the models see variable and trends in climate, you see that the ocean carbon sink still increases through time, so it's not a first-order effect, but it increases more slowly than the ocean would if there was no changes in climate and no variable climate. The difference between the 2 lines is shown at the bottom, which highlights the signal, which is the impacts of climate change and variability as modeled over that period. And the underlying, the beauty of the model is you can then go dig for processes, and the underlying process is that the model responds to an increasing wind in the Southern Ocean, which has been observed, at least partly from changes in the ozone depletion in the stratosphere, and also as estimated by, inferred from analysis by changing climate. By increasing, so when the winds increase, it increases upwelling, so it's bringing back to the surface carbon-rich waters from the deep ocean to the surface, and that is preventing further absorption of anthropogenic carbon. And the link between the winds and the change in carbon uptake is illustrated here with this wind index. Is a smooth version of the southern annular mode, for those who know, and which shows stronger winds downwards, and it shows a very nice correlation in this model result with stronger wind downwards. The existing observations are a bit too short at the moment to really say whether this has been going on for so long, but you see that the signal based on observations overlaid in red actually suggests that at least the part of the variability is correct, although there is still question on the amplitude, the exact amplitude of the response. And this is where we are with the carbon cycle analysis, and many of the components is that we see change, we see the direction of the response. We're still a bit challenged on the amplitude of the response, both direction with overestimates in places and underestimates in other places. And what I've said about the ocean carbon cycle is also true in the terrestrial realm, where feedbacks between climate change and the carbon cycle occurs on land, where warming and changes in rainfall trigger a reduction in the efficiency of the uptake of carbon by the terrestrial biosphere, mainly through reduction in tropical forests and also thawing of permafrost at high latitude. This has led the IPCC to state in their last report that climate change will affect carbon cycle processes in a way that will exacerbate the increase of CO2 in the atmosphere. And just to give you an order of magnitude here, that this century, the climate carbon feedbacks are thought to account for about 5 to 30% of the further warming to climate change projection. Most of these feedbacks, not permafrost, are included in the climate change projection. There's an estimate of the feedbacks of permafrost, which this century is the same ballparks of the other carbon cycle processes. So that closes the science. I'm speeding through this talk, am I not? It's okay, I'll take my time on the future we choose. Here is another picture of me. This is the best picture of me after my wedding picture. And I was a lot more smiley on the day of my wedding. You can ask my husband, who's here. On Sunday, the 25th of November of last year, 2018, I had a phone call on my mobile from the office of the French President Macron, asking if I would chair his new independent council called High Council on Climate Change, so Conseil pour le Climat. This is an independent group of experts, they said, to evaluate the actions of the government in the long term and make recommendations. So essentially assist the government in the transition to a low carbon economy. It was inspired by the UK Committee on Climate Change, which has been advising the UK government for a decade, over a decade, very successfully, I think. In this picture, you will have recognized by now, I'm standing by one of the most powerful person on the planet, up there with the German Chancellor. I am actually terrified. Although it doesn't really show. We have now changed gear on climate change. Dealing with climate change is no longer the responsibility of the environment minister. In fact, if you look to the right of this picture, the Minister of the Environment was struggling to get into the frame. He had to go on his tiptoe. Dealing with climate change is the responsibility of presidents and of prime ministers, of ministers for the economy, for health, for transport, the ministers that have the big budgets and the ministers that take the big structural decisions. We need climate and all this in the presence of an environment minister. Of course, the environment ministers are super important in making this happen. We need climate change policies, but we mostly need that current policies that haven't necessarily been developed to tackle climate change. We need those policies to be coherent with moving out of fossil fuels. We need policies for transport, for buildings, for industries to be revised so that they are coherent with a net zero economy and moving out of fossil fuel as quickly as possible. This transition to a zero carbon world is the biggest challenge we have faced so far, I believe. Although we are seeing incredible awakening this year, there has been a pushback. It's not been all rosy. In France, the rise in fuel tax set up to fight climate change was the trigger for the biggest protest in France in decades and led to the freeze of the carbon tax. In Ecuador, the removal of fossil fuel subsidies, as recommended by the United Nations, triggered 5 days of riots in Ecuador before the government backed off. In the Netherlands, measures to tackle emissions from agriculture sent angry farmers to block the roads, protesting that, what are we thinking of? They are feeding us. And Extinction Rebellion protests in the London Tube last month turned into a near lynch of the protesters by angry commuters. We have come a long way in addressing climate change. We have the Paris Agreement. Action has started, and we now need an organized plan to get us out of fossil fuel and into a low-carbon economy. The plan needs to be fair. It needs to be well prepared. It needs to engage citizens and businesses as far as possible, but this has to be led by governments. Here's a new piece of research that I want to share with you. We have, with my colleagues and I, last year, we have decided that we had enough of depression, looking at climate change all the time. We were going to look at the countries that are decarbonizing. So we looked around the world in the period 2005 to 2015, and we took all the countries where emissions of CO2 from energy here were decreasing significantly over this 10-year period in the presence of a growing economy, and over territorial and consumption emissions for those who know the subtlety. So by measures on the ground. And you see the UK is there, you see Germany is there, although I have to say it barely made it, just 1% significant. France is there, and many other countries, Scandinavian countries, and so on. And we looked across these countries and said, well, what works across this country? Can we learn things that has worked across this group of countries that has led to reduction in emissions? And there were 3 factors that were common, not to all countries, but sort of emerged from the packs. One was these countries were using less energy. In fact, there was a decrease in energy use in this country. It was very unusual. The second one was that renewable energy were deployed massively and fossil energy was removed from the market, so renewables were replacing fossil fuel. And the last one was a correlation, so we couldn't do a strict cause and effect, but from a correlation we could see that the countries that had more policies in place also had the bigger reduction. So these factors were common, a lot more than, for example, the switch from coal to gas, which was a factor in the US, not the biggest. The US had a more distributed portfolio of changes. And also, it was bigger than improvements in, for example, transmission and efficiency in the production of fossil fuel, which hadn't changed mostly across countries. So that did, in fact, give us quite a lot of hope of possibilities and the capacity to learn across countries. Now, I want to spend a few minutes about what it is that we need to do next. So I've been looking at these emissions for a long time, and I listened a little bit to the public and so on, and I think that we lack a little bit of a global picture of where is it that we are going with this transition. And because I look at these figures so much myself, I find that it's in fact not that hard. And it's not mysterious. We have all the technology, we have the know-how, for example, these efforts here. And we can break it down relatively easily, which I'm going to do just now. I'm going to paint you a picture of what it is that we need to do. Our emissions come from 4 places. They come from transport, from buildings, from power and industry, and they come from the way we use land. So in transport, in fact, it's quite easy. In city centers, we can walk and cycle. So you find the funding, build the cycle path, promote the idea, change the culture. In cities and suburbs, we can share transport. So you need to find the funding. You need to expand the network, improve the service, and change the culture. And outside cities, vans and cars go electric. Secure the funding, build charging points, subsidize cars until the price go down enough, learn to recycle batteries. Trucks go on hydrogen, secure the funding, produce the hydrogen, phase out petrol and diesel cars across, diesel engines across the board, and as an extra, we get clean air in cities. Now buildings. That's heating mainly here, 40 million house. Secure the funding, insulate whole roofs, most walls, install digital kit to be more efficient, produce heat pumps, build skills, install the heat pumps, refit radiators in places, develop heat networks, fit houses, build ultra-efficient new houses, check the performance, check the compliance, phase out gas boilers, and as an extra, the houses are more comfortable. For power and industry, build the electric capacity from wind power, offshore and onshore solar power, hydroelectricity, some nuclear, some biomass, strengthen the grid, develop storage, develop peak management, peak demand management. In industry, use electricity where possible, in hydrogen where not, develop carbon capture and storage. With the know-how of the fossil industry, fit carbon capture and storage on the biomass power with carbon capture and storage to offset some of the emission from aviation so that I can go and see my daughter in America. Inland, for the use of land, improve our health. Eat more vegetables, less meat and dairy, grilled vegetable lasagna, beef burger, falafel and hummus, pokeballs, vegetarische Thüringer Bratwurst? Vielleicht nicht. Beer ist kein Problem. Chips and beans on toast. Chefs become creative in the vegetable department that releases land. We plant trees, expand woodland, create habitats for birds and hedgehog. We harvest some of the wood, build in construction with wood, expand the wood industry, restore peatlands, restore other ecosystems, and as an extra, we increase our resilience to climate change. Meanwhile, we work with our friends internationally. We build alliances, support developing countries. We do not focus on the United States for next year. Every 5 years, the Paris Agreement becomes stronger from those countries who act. Fossil fuel disappears. Countries implement their commitments into law. global reforestation is on the way, the tide turns, and children go to school on Fridays. Variations are, of course, possible, but it is not so difficult. It takes time and it takes preparation. I have to say that after I wrote the IPCC, I thought, actually, I'm done now. I've done my job. I'm a scientist. I will hand it on to politicians. And then I saw this survey here, the Ipsos-Mori survey. They do this survey every year, and they ask the question, who do you trust? Do you trust these people to tell the truth? And if you look at who's the most trusted is nurses and doctors, but scientists are in fact right there at the top. And I'm very sorry to say that journalists are at the bottom. I think that's not deserved actually, but who am I to say? And politicians are also at the bottom. So very unfortunately, it does mean that there is still a role for a scientist, which is to ensure that the numbers match. I see a lot of promises, a lot of commitments for action, a lot of actually action even, but the numbers don't match. The action is not at the right level at the moment. We have to raise the action across society so that we can get there to net zero emission on time. So I want to end with this here. Now, dealing with climate change is the first global issue that we need to solve on the transition to global sustainability. That simply needs to happen because of this year, because of what we all know, because of the dominance of human population on the planet. You see it here, the world population has doubled in my lifetime, which was actually somewhere in the middle of this curve here, an incredible change in the way that the planet operates now. It is thought, based on demography, that the population will stabilize or at least reduce growth at 10 to possibly 11 billion at the end of the century. This is a World Bank projection here. But I like to see this graph, in fact, with a slightly, just like a fraction of a longer x-axis here. 4,000 years in the x-axis, and I think it is very useful to see the past 100 years in a slightly longer time frame to appreciate how unique this period of history is, and how lucky we are that in spite of the responsibility that comes to us with knowledge, to have the chance to shape the future of the planet, not with guilt, not with cynicism, but with a course of concrete actions recognizing the times in which we live and the opportunities ahead of us. Was für eine Chance in diesem Moment zu dieser Zeit zu leben. Historiker werden Bücher über uns schreiben. Ich habe in meinem Leben schöne Dinge erlebt, die ich kaum glauben konnte. Und doch werde ich das Gefühl nicht los, dass die Zukunft wahrhaft Unglaubliches birgt. Dankeschön.
Thank you so much, Corinne, for this terrific talk. I think we all gained a lot of climate literacy, whatever our state of knowledge was before. And you brought us all the way through the IPCC reports from the physical basis to climate action. So I invite you to come up with a few questions. And I think there are some microphones in the room, so they will find hopefully the way to you. But as I don't see anyone now, I will start with the first comment and question myself. You mentioned the global carbon cycle.
Yeah.
You led us through that and all the different levels, and we are not talking only about the atmosphere, but for example, also about the land, terrestrial CO2, and also the oceans. And you pointed to the hope that the oceans continue to buffer us in a certain way. But there's also some risk involved there, in the sense that already now, warming oceans and the acidification that comes along with the CO2 actually help to destroy the coral reefs, like one of the first direct impacts of destruction of ecosystems, and of course it boomerangs already back to us with a lot of livelihoods lost because of that. So in a certain way it's already beyond climate change alone. But I would really like to ask you a big questions on the governance. And you mentioned trust at the end. And you mentioned some hope in action, but also the problems related to the Yellow Vest protests in France, Ecuador, and some other examples. Now, like one big question that I'm grappling with, and I'm not sure about, but I'm more tending into one direction, is the question whether we focus on climate action just alone, or whether we should see it as a Green New Deal, where inequalities are tackled at the same time. And I thought, no, inequality is a big issue, but it's not related. Don't talk about it, we focus on climate change. But I see two issues now. The first one is, like, if you want to implement something like carbon taxes that are usually seen as very effective instruments, you need a lot of trust into governments. And the second scientific finding here is actually that there's more trust in governments when societies are more equal. So my thinking now goes in the direction, yet when you do climate policies, also think about equality and trust in governments at the same time. I would love to hear your thoughts on this.
Yeah. Thank you very much for your question. I would like to just say, before I go to the trust issue, just a few words about governance. We now live in this shared planet with this big population, and there's a lot of stress. And our governance is not fit for purpose. We have governments that rotate every 5 years, yet these problems are much, much longer than this. We have not got any safeguards internationally, just a little bit starting now with the Paris Agreement. We have to step up the governance. And I think the establishment of the committees on climate change is like a beginning of this, where governments establish a body that is in charge of looking at the whole pathways over a long time. And I would very much encourage, for example, the European Union to look along these lines as well. It's very difficult to think about issues today when the problems actually are established over a long time. So looking at the governance, both at the country level, but also at the international level, is very important. And when this is set up, you can actually set up bodies to cover more than climate change action. You can have also biodiversity and other issues that are related. On this issue of fairness, I have come to realize that this transition has to be fair. The costs and effort has to be distributed transparently and fairly across society, both nationally and internationally. Everybody has a role to play, so it's not that the rich will pay and nobody else will pay. It's not that the poor will get most of the burden. It has to be distributed with everybody having a burden that is acceptable and manageable for themselves, and opportunities that are best for them as well. And you see it from the demonstration, from the pushback here, when there was a perception of injustice, people go in the street straight away. There is a lot of resentment that comes with action that pull things away from you, and therefore people, sectors of the economy, businesses have to be prepared for this. And of course there will be lots of opportunities, and some sectors, some actors and people who slipped in quickly will gain, but many people will not perhaps have the opportunity or the agility to grab those opportunities, and we really must take care of what happens to these people because it's not going to work otherwise. And this is the feeling of justice, we know it. It's a very, very powerful feeling. And when it's unfair to us, we know it straight away. And this comment applies as much as at the country level as it applies internationally.
Thank you. Do we have any questions in the audience? There are 2 questions. Could we have a microphone over there? Here? And please, can we just have the 2 questions immediately after, so then we can collect them? Thank you. If you also could shortly introduce yourself.
Yeah, hello. I'm Johannes. I'm studying at TU Berlin, computer science. My question regards some of the presented solutions which should tackle the climate change, which are like batteries and maybe even nuclear power, which is not used in Germany but in many other countries. And I sometimes feel like that many of the solutions proposed have very significant downsides in the long term, maybe regarding nuclear waste, regarding battery waste, and sometimes I feel like if we just use these solutions in the long term, we might get some very big problems, like dramatically decreasing biodiversity and stuff like that. And I would like to hear your comment on that.
Thank you. I think behind you is also another question. Thank you.
Yeah, Berit Müller from the GGS, German Association for Solar Energy. And I mean, you must have waited for this question. He already posed, like, why did you include the nuclear energy, though you know there's a lot of waste, which is risky, the technology itself is risky, and it's more expensive than new renewable energies. So I would like to know why you think it's a good measure.
We have 2 questions, so it's both in the same direction.
Yeah, thank you. Yes, that's right. So are the solutions worse than the status quo? I mean, we can act on batteries in particular. So there's been a lot of progress in the recycling of batteries. I mean, this is the role of the policies that are put in place to, in fact, ensure that batteries are produced and recycled carefully. It's not the only solutions in transport, so sharing transport is also a solution which would reduce the amount of batteries that would need to be in place. This is the kind of thing that needs to be discussed when solutions are implemented, in fact, by either advisory boards or by governments itself. It can be done through discussions, through citizens' assemblies, and so on. If we just reject all the solutions, then we just stay in the status quo. On nuclear energy, I mean, this is a tough thing. From my perspective as a climate scientist, the electricity needs to be decarbonized, and the choice of decarbonizing becomes a societal choice. If this country prefers to have renewable energy and manages the load with renewable energy, I think this is very good. If the load cannot be managed, or if some nuclear energy is good in this mix of electricity, I'm also fine with this. This is not a choice for me. This becomes really a societal choice. But at the end of the day, you have to have the renewable electricity. You have to have the low-carbon electricity. And there is a number of ways you can achieve this, nuclear being one of them.
Thank you. Other questions? We have one question in the middle there. Can we have the microphone over there, please? And then to the front here. A second microphone here to the front. I think it's over there. Yeah. Yeah, thank you. And the second mic, please, here in the second row. Thank you.
Hi, I'm Jasmine. I study industrial engineering here, and I was wondering, with the graphs of the 18 countries that have decreased their carbon emissions over the last few years, does that take into account their carbon outsourcing, and how big of an issue is that still? And is there anything that policy-wise is happening to stop that?
And your question, please, too.
Hello, my name is Koray. I'm a student from the Sophie Scholl Oberschule. We had the European emission trading system for the last 12 years, I think, and it didn't really work quite out. Do you believe we have to take more drastic measures to stop the climate change?
Thanks for the succinct question.
On the outsourcing, and this is a really, really good question. So the question is that countries, some of our emissions are in fact accounted elsewhere. For example, if we buy a table today, this table might have been produced in India or China, and the emissions for producing this table is accounted there, and yet we have the pleasure of holding our glass on this table here. And consumption emissions are big. In the UK, they increased UK emissions by at least 50%. More importantly, and this is because of the trade, the UK has a lot of trade with other countries, and more importantly is this decrease caused by, in fact, moving the industrial production outside of the country. And in fact, we selected the countries where the consumption emissions were decreasing at least as fast, or were also decreasing at the same time as the production emission. So the simple answer to your question is that no, this was not a factor, because we selected the countries where it did not happen. In the UK, in that period, 2005 to 2015, it is actually measures at the country level that have caused this decrease. I do want to just dig a little bit here, because I think consumption emissions mentally block people from acting on climate change. And we can't focus too much on consumption emissions because you don't control them that much. You do control consumption, so you don't control zero. But you don't control how much carbon emissions go into these products and services. And there's a lot that you can do to action on the ground, in Germany, for example, that will reduce both territorial and consumption emissions. For example, everything you do to decrease, to become more energy efficient, decreases both territorial and consumption emissions. Everything you do in the food department for moving away from or eating less meat and dairy decreases also consumption emissions. And if you put the efforts that are made in this country and in the UK in the global context, and the global emissions are also eventually are going to also decrease down to zero, then automatically the emissions associated with the consumption emissions will decrease down as well, not perhaps at the same time as the national emissions, but they will decrease. So I think we need to not focus too much on this consumption emission, although I think that we could dig a little bit more, because there might be measures that we could put that would encourage, in fact, other countries to decrease their emissions faster. On the ETS not working, this is a price issue, and there has been a revision of the ETS through time that I believe the last revisions has put up the price quite a lot and led to much more effective EU ETS. The emissions have decreased in industry, partly because of efficiency measures and partly because of move away from fossil fuel towards more renewable energy. So I think it's not a black and white picture there.
Thank you very much. There are certainly more questions, but there's also probably some appetite to the after program. So I would like you to join me for another big hand to our speaker.
Thank you so much.
Oh.
Thanks.
Oh, yes. Oh, sorry.
Thank you. So we have this Urkunde, which is what the Germans like to pass out, We would like to thank Professor Corinne Le Quéré, Royal Society Research Professor, University of East Anglia, for the Queen's Lecture 2019 entitled The Interactions Between Climate Change and the Carbon Cycle and the Future We Choose, the President of TU Berlin. So thank you very much again. We have also a small present.
Oh, wow.
Thank you. So we got more. This is a piece of research that I understand you have been involved in yourself. If you look from afar, a globus. If you look from close, you see it has little pimples which are proportional, their size is proportional to the amount of carbon dioxide emission that the various countries have. And so whoever would like to have a look at it is certainly welcome. We thank you again for being here.
Thank you.
Corinne Le
Thank you.
Quéré.
Thank you. Very nice. Okay, very good. Thank you. Okay. I will maybe leave this.
And the last thing I would like to do is ask the ambassador, Sir Sebastian, to come up once more. We'd like to thank you as well for giving the pleasure to listen to the Queen's lecture. We have the globe in form of a map. It's the same globe that we just gave to Corinne Le Quéré, and you see the size of the bubbles are proportional to the carbon dioxide emission. First approximation, United States is very big, then China is very big, and then it's too small for me to see without glasses, so maybe we have a chance. You're welcome. It's a selfie, I guess. Thank you very much. So you're all invited to the reception upstairs in the Lichthof that you well know. Thank you very much. The session is closed.